Okay, so our topic today is simplifying radicals. So I'd like you to write down what we did yesterday. Yesterday, we were finding square roots. We were relating the area of a square to the side of a square. So go ahead and write these down. Okay, so what this is saying is that if I have 3 times 3, I get 9. Or the square root of 9 equals 3 squared. And when I have a square underneath a square root, they're inverses of each other, and I get 3. Let's talk about that for a quick moment. If I were to tell you the side of a square is 3, could you tell me the area? If I tell you the side of a square is 3, then what's the area of that square? Good, 9. How do you know that? Because 3 squared equals 9, correct? What if I told you the area of a square is 9? Could you tell me the size? How do you know? Because the square root of 9 equals 3, correct? Or I should say, the square root of 3 squared equals 3, correct? So these are what? What do you see there? Almost. One is the square root and one is a square. So what are they? They're not exactly the same thing. What do we say when we have something that looks very similar, only they're opposites? Almost. Almost reciprocal. We call them inverses. Right? Everything in math is inverses. So, basically, what this is all saying to us is that if I have the area of a square, then the side of that square is the square root of that number. Okay. Let's move on. So couldn't we also say this? If I know the area is 9, couldn't I say that the square root of 9 is the side? Because doesn't this mean 3? But you've probably never seen it that way before, right? But how do we find the area of a square? Don't I just multiply 3 times 3? So couldn't I multiply the square root of 9 times the square root of 9, which equals 9 squared under a square root, which equals 9. Make sure you have that down. Let's look at one other approach. So does this mean the same thing? The square root of 3 squared times the square root of 3 squared equals 9? Because these are inverses of each other. So we get 3 times 3 equals 9. So I just showed you 3 different ways to write the same exact thing using square roots. I would make sure you have that written down. So does it make sense that where did they come up with that word square root? Well, if we have a square and I tell you that the area of that square is 25, then what's the root of that square? How did you come up with the square? The root of it would be a 5 by 5, correct? That's where the root comes from, is that if you have a square, then the root of finding that square will be I need a side times a side makes a square. Okay, let's move on. Okay, so let's work off of this. If 3 squared, the square root of 3 squared times the square root of 3 squared equals 3 times 3 equals 9, then what could we do with the square root of 75? Good, you're seeing squares in there, right? In order to simplify this, we need to find the squares. So let's begin. I'm going to change my colors quite a bit here so we can get the idea of this. So 75, the square root of 75, is actually, I heard somebody say a square, 25 times 3. Does everybody see that 75 is actually 25 times 3?
Yep.
3/4. Change my color. Couldn't I also say that that means 25 times 3? From what we were just doing with radicals, can't I do that? Doesn't it mean the same thing? Which doesn't 25 mean 5 squared times radical 3? And when I have a 5 squared underneath a radical sign, aren't those inverses of each other? So they just cancel each other out? Just like up here, 3 squared makes 3. So I have 5 root 3 as my answer. Everybody have that written down? All right, let's move on. Let's begin with this one, the square root of 24. Anybody see a square in there? Let's start with 8 and 3. We could. 8 times 3 equals 24. Anybody see a square in that? I see 4 times 2 times 3, which equals, can I break them all up? I don't really need to, I can say 2 squared times, is there any square in 2 and 3? No, so I can actually just combine those, which is 6. So finally I have 2 rad 6. Let's try the next one. Square root of 60. What do you see in there? 6 and 10? Okay. 6 times 10. Where can we go from there? Go ahead. 2 times 3 times 2 times 5. Good. Then from there I could say 2 squared times 15, because I don't need the 3 and the 5 aren't going to do anything all by themselves, right? So finally, I have 2 radical 15. Got this one. Let's step it up a notch. Couldn't I say 9 times, let's break up 12. 4 times 3. Everybody see how I did that? Can I do that? What property am I using as I'm doing this? Commutative, good. I can break things up, move them around, right? And factoring. Alright, so now what do I have? I have a 3 squared. I have a 2 squared. And what am I left with? A 3. What gets kicked out? inverses. A 3, a 2, what's left over? A 3. So this actually simplifies to 6 root 3. So far so good? Let's jump on this one. Take a leap. What's really in here? 7 times 4 isn't 4 squared. So isn't it 2 squared times radical 7? Which equals 2 radical 7. Is that too much of a leap? A little bit? Okay, so let's look at these. So couldn't I do the same thing? These are just separated a little bit. So do you see any squares in here? No. So all I can do with this is just simplify them. That's really root 10. What about this one? Patrick, do you see anything in here? Nothing? Nothing of interest. I've got a 7 underneath the square root, and I've got a 14 underneath the square root. Nothing of interest? 2 has something of interest? You're just being stubborn. You don't see anything in there. Nothing that has to do with the 14. There's a 7 in there. I've got a 7 in here, and I've got a 7 in here. So don't I have 2 7s? Times what? Times 2. Right? Is it too much of a leap? Let me back up. See how I multiplied these? 2 times 5 is 10. Couldn't I also multiply this and factor at the same time? 7 times 7 times 2. Which equals 7 squared times radical 2. See it? Which equals 7 radical 2. Same idea here. What's in here? There's a 3 and a 2 over here, so don't I really have a 3 times a 3 times a 2? Which equals 3 squared? Because 3 times 2 is 6. Right? So I've got a 3 times a 3 times a 2. You see it? Without a square root. This right here? Let's do it over here. See it? I have a 3 times a 3 times a 2. So finally, this would be 3 root 2. What about this one? Worry about the inside, worry about the outside. Couldn't I also start moving things around with using commutative property? So don't I really have a 4 times a 3 times a root 3? Let's break it all down. Times a root 3, isn't root 15 root 3 times root 5? I could break it down that way, right? Let's simplify a little bit more. 4 times 3 is 12. And over here I've got root 3 squared times root 5. So it can be simplified even more to say, what gets kicked out? 3, and 3 times 12 is 36 root 5. Everybody see where I got it? Am I going too fast? Let's write that down. So finally, what's the difference between these two radical expressions? First of all, why do I have a 2 right here? Anybody know? Because it's a square root. Right? We don't normally see it like this because it's kind of like a default. Just like when I see the number 8, I automatically know that it also means 8 over 1. So when I see a square root like this, it automatically is a 2. Except when they put another number in front of it. So what does this mean? A cubed root. Good. Let's talk about the difference between these two things. What does this represent geometrically? What? 2? It means something specific. It means a square. Good job, Elgin. Means we're talking about a square. We're talking about the area of a square, and we're talking about the side of a square. Right? What's this one? A cube. So we're talking about the volume of a cube and the side of a cube. Everybody see that so far? One more thing. What's the answer to this?
64.
No. It's got a 4 times 2 in it, so it's 2 rad 2. That's the side of the square. So this is an 8. What's the cube of this? Which is 2. That means each side of this is 2, which makes this a volume of 8. That's the difference between the two. Okay, guys, have a good day. Hold on.